Hey students, our job in this video is to quickly review the key ideas behind charging to hopefully support other readings or things that we did to prepare. Okay, we'll go over the basic intro stuff and then focus on the three types of ways that charges might move or realign themselves depending on a given situation. Okay, so the first thing, what is charge? Charge is kind of like mass. There's this property that material have, and we call that property mass, things we measure in kilograms. Turns out there's another property known as charge. And by experiments, we see that there are two types of charge. And just because there are two types, we call one a positive charge and one a negative charge. Protons we label as the positively charged thing. Electrons are negatively charged. And protons and electrons, while they don't have the same mass, protons are much bigger, they do have equal, but opposite, amounts of charge. When we do experiments, we see that things that have opposite charges attract to one another. Positives and negatives attract. But if you have two things with the same charge, they repel, they hate each other. Minuses and minuses want to get as far away from each other as possible. Pluses and pluses, they also don't like each other. Okay? If we look at my picture of an atom right here, we see the electrons are the things that are floating in these outside orbital shells. Electrons are zipping around, moving around freely. And in materials like metal, conductors, these electrons can move around so freely they can even kind of wander around through the material. They're often not even bound to the atom that they were originally next to. The electrons can move freely. The positively charged protons, however, they are locked in place. They are in the nucleus of an atom. They actually cannot move. And that's a key idea, because when we're talking about charging, because the protons are locked in place, we are always talking about how the electrons move. If something becomes positively charged, it's because electrons must have been taken away, leaving behind positive charges. If something becomes negatively charged, then electrons must have been added. But we will not be talking about protons being added or removed to a material or from one place to another place. That's simply not happening. Last thing, I kind of skipped over it. If something is neutral, just means there's an even number of positive and negative charges. Before we talk about our three mechanisms of charges moving from one place to another, I want to talk about a key term you might come across known as grounding. If something is connected to the earth, we say it's grounded. And that makes sense if you just kind of think of the word, think of like the ground, the soil, the dirt, the surface. Okay, you are grounded if you're touching the earth. And that's important when it comes to charges because the earth is really big and it has an innumerable amount of electrons and it has a huge amount of space. So because of that, if something is charged, if something is negatively charged and it touches the earth can take in those electrons. There's plenty of room for those electrons to repel into the earth and spread apart. If something's positively charged, electrons from the ground could pretty easily move up into that positively charged object. So the earth can give electrons, the earth can take away electrons. And that often means that if something is grounded, usually it's becoming neutralized because those extra electrons could be taken away or those missing electrons, if something's positive, could be added back in. There's a symbol for grounding. This is the circuit symbol. We might see this every now or later. We won't see it that often. But there's another type of grounding. If you have something big, like a person, compared to a small little metal device, even a person can ground an object. Humans are pretty big. We have a whole bunch of electrons. We have a decent amount of space. If I have this, it looks like a negatively charged object. If I just touch it, some of these electrons, remember, they all hate each other. They repel. They will move into the hand. So a person could ground an object as well. Okay, let's go over our three different methods of charging. The first is known as polarization. And that's if I have an object, here I have like a blue, maybe a metal sphere, And right now that object is neutral. And I know it's neutral because there's an even number of pluses and minuses, 3 pluses, 3 minuses. Okay? If I polarize it, it means the charges rearrange themselves within the same material. Okay, here's an example. Let's say I take this neutral object and I bring something very negative nearby. Well, this is negatively charged. There's still a gap. Electrons aren't going to jump ship. They don't like moving through the air. That takes a lot of effort. But these negative charges are going to make some of these negatives repel away. These negatives don't like this thing. They would rather get as far away as possible. So instead of being in their original spots like that, instead they're going to move over. So the electrons are like, oh man, let's get as far away from that gray bar as possible. So the electrons will repel to the right. Well, if a whole bunch of electrons repel to the right, what's left behind on the left side are positive charges. I am not saying that protons moved over. That is not happening. What's happening is any electrons that were over here, they slid over to the right, leaving behind positives. If there are now fewer electrons, there are more protons. So they're positive charges. That can get a little confusing. Notice this whole object is still neutral. There's still 3 minuses, 3 pluses, but they've polarized. The charges have realigned themselves on one side or another. But nothing's jumped across. There's still an even number overall. They've just rearranged. That's polarization. Next one, induction, building on that. Let's say I have 2 neutral objects. Again, I have 3 pluses, 3 minuses, 3 pluses, 3 minuses. This time they're touching. And if they're conductors, they're metal, not only can electrons move around in the individual object, but it's like there's a bridge. Electrons could move across objects. So if I have this initially, and then I bring a very positively charged thing nearby, well, these 3 electrons, they might be like, hey, let's move over there. I'm going to actually draw in the pluses here just to, again, emphasize that they are not moving. I'll try and put them in the same spot. So those pluses, they are not repelling. They can't move. But these negative charges, they would move to the left. But not only that, these negatives, the negatives that are over here, they see something on the left that they also really like. Not only might those negatives move to the left side over here, they might add at least some of them to this sphere on the left-hand side, all to try and get closer. Maybe they all don't move over, but some of them will. Okay? If I keep those original pluses, notice what I've done. Just by bringing something close by, this side is now negative, there's more minuses. This side is now positive, there's fewer minuses. Nothing positive moved over. If I then separated my 2 objects, I have polarized, I'm sorry, that's not correct. I have charged these 2 objects without even touching them. This one is now positive, this one is now negative. You are inducing a charge. You're causing the 2 objects to gain a charge just by bringing something close by. So that is induction. This one's now negative, this one's now positive. That's induction. Last one, last slide. Apparently my battery is charging. That's strange since my battery isn't plugged in. Conduction. Conduction is saying if I have something that's charged and it's touching something else, and it could be neutral or it could be charged as well, charges might move across to balance themselves out. So I have 2 objects, that's annoying, and then I'm going to bring them together. And we're going to look at how charges might rearrange themselves. And I have 2 different examples. I'll start off with example 1. I have negatively charged objects in blue. I have a neutral object in orange. I could also represent neutral by just not having pluses or minuses drawn at all. I really hope that stops soon. Well, these negatives clearly hate each other. They want to get as far away from each other as possible. Right now they're kind of stuck. But if I bring them together, there's a bridge. Some of the electrons will repel and go to the right. I guess I should change color. Let's see. I'll pick black. some of those electrons are going to repel over here. So instead of it being neutral, it'll be negatively charged. So 3 maybe moved over, 3 left behind. Okay, 3 stayed here. It's like if you're in a room with 6 people you hate. Okay, if all of a sudden another room opens, half of you, it would make sense, will go to the other room. You wouldn't all go to the other room. That wouldn't work, because now there'd just be 6 of you over here. You would try and make the hatred as minimal as possible, and you do that by splitting up. Likewise, if I had like 4 and 2, well, that doesn't work either, because there's more hatred over here. It's kind of easy once you get to understand the process. They're always going to balance out as much as they can. So now they're both negative, but they're not quite as negative as the original one over here. Okay. The second example, I have a positively charged object. This one is still going to be neutral, but I did draw in the pluses and minuses just because it's a little easier to show. So now something's really positive. It's missing electrons. If I bring them together, okay, I'm still going to draw those pluses because remember, they are not moving. Plus, plus, plus. Any electrons that were in this positively charged object, they have no reason to leave. They're happy. If you're in a room filled with 4 big piles of candy, you are a happy person. There's no reason for you to go into a room without any candy. But some people in this room, they might be like, hey, there's candy over here. Some of these electrons are going to move over. Okay? If an electron moves over, let's say an electron adds in, boop. Well, now that electron just kind of canceled out that positive charge. If another electron moved over, boop. Well, now those two kind of cancel out. If a whole bunch of electrons moved over, like 30 of them did, well, that wouldn't really work because then eventually this one would become really positive as more and more electrons left behind. The number of electrons that are going to move over will be enough that balances. So if I started off with 4 pluses and a neutral object, I'll end up with this because a couple electrons moved over. When an electron moves over, it'll cancel one of these pluses and it leaves behind a plus, creating a positive charge. Okay? So to be honest, the quick approach is just to divide up those charges. But it's again important to understand what's happening. Okay, electrons are moving towards positives or away from other negatives. That's conduction. That's all I got. Thanks for listening.